My name's Ross Ramsey. I'm an environmental engineer for a company called Mabit. My role for the last 10 years has been linked to energy efficiency in various shapes and forms. I started at the Building Research Establishment and did some work on case studies and best practice guidance for energy efficiency. And I've been working at Mabit now for about 6 or 7 years, where an awful lot of my work's been related to energy surveys, energy audits and energy improvement programs for clients of various shapes and sizes. So what I propose to do today is split it into 3 sections. So the first 15 minutes, I'm going to talk a little bit about the basics of energy management, give you a feel for that. Middle 15 minutes, I'll talk about some of the actual practical examples of where you might look to save energy and give you some personal experience on that. And then for the last 30, 45 minutes, I've got some slides, but I'd rather we had some sort of discussion, get some feedback on what your own interests are as well. Okay, so in the first 50 minutes we'll cover a few things, the drivers for energy efficiency. So why is it worth bothering about, what's all the fuss? Where is your energy going? That's an important point, and I'll come back to that in a moment or so. So you want to know what your biggest energy consumers are, and that allows you to effectively manage it. And also how can you actually achieve energy reduction? How can you manage your energy consumption? The main reason you're probably all here is to do with energy costs, and that's a primary driver for people who want to save energy. There was a good presentation this morning about energy issues in Northern Ireland, and that was talking about the supply side costs. So what are the factors that influence the actual cost of electricity and gas and oil in Northern Ireland? We'll be talking about the other side of the coin, so that's talking about how you can manage your actual energy use and so reduce your costs. Energy prices over time, I've rather crudely drawn a straight line through that. There was a much better presentation on this morning actually. But although it's crude, it's probably fair to say that in the near term your energy prices are probably going to rise, and there's also some volatility around that as well, as you can see from the underlying chart there, which creates its own problems. The reasons for this, I'll talk about this briefly. In the late 19th and 20th century, we've been able to benefit from very easily accessible fossil fuel reserves, and that's what's driven most of the economic miracle of the 20th century and so on. So that was easy access oil and easy access coal. There's more and more problems associated with those, so oil's not so easy access anymore. Coal has its own environmental drawbacks, so we're starting to try and use other energy forms. So renewables, which there was a good discussion on this morning as well. There's other forms that people are looking at, like shale gas extraction. That's caused quite a fuss in the US at the moment. I don't know if you saw it in the news last week, but there was also something about another form of fossil fuel that was previously thought to be inaccessible in Japan called methane hydrates, and they think they have managed to access those, and they may be able to practically use those methane hydrates in future as well. But the bottom line is that in comparison to say 50, 60 years ago, the actual cost of extracting energy from the various resources that we have is becoming a bigger percentage of the actual energy payback that we get at the end. So what it means is, if you like, the energy return on investment is becoming lower than it's been in the past, and that has implications for our economy and for our businesses and as individuals as well. Other drivers, obviously there's legislation, so there's a government telling you to do something or encouraging you to do something. I don't know if any of you are familiar with energy performance certificates at all. Anyone been drawn into that? That's a development from the product labelling systems that European governments developed previously for things like dishwashers and washing machines, and it's applied to buildings with varying degrees of success, I would say. There's other things as well. I don't know if any of you have been the subjects of air conditioning inspections. Some of the larger companies here today might be involved in carbon reduction commitment, things like that as well. And behind all these legislative drivers are the environmental impacts of energy, which foremost amongst which are carbon emissions, which is the thing we always see about in the news. And you might argue rightly so, because of the scientific evidence, which is becoming stronger and stronger each day, points towards it having quite dire consequences for our society if we don't do something about it. But in any case, this isn't the core I want to talk about today anyway. I'll rather bring it back down to your own level and talk about how energy affects you. So, as I mentioned earlier on, one of the things that's really valuable in terms of energy management is to try and get an idea of where energy is going in your organisation. So, an example here is a sawmill wood. So, we did an energy survey for them, and we were able to say with a kind of reasonable degree of certainty that 36% of their energy is going into their bandsaws and 17% is going into their air compressors. And what that allows you to do is start to target your activities in terms of energy management. So there's not that much point in spending a lot of time in thinking about how you might improve the efficiency of the debarker as opposed to the bandsaws. Now, there's a number of ways you can tackle that. There's some best practice guidance available. So if you have, for example, an office or a commercial building, typically what you'll find that the pattern of energy use and energy consumption is quite similar from one to the other. So in most offices, about 50 to 60% of their energy is related to space heating or air conditioning and those kind of things. And there's best practice guidance available for you about how we do that. I'll talk about some of those sources of best practice later on. Also, half-hourly data. I don't know if any of you have or have accessed half-hourly data at all. If you have an electricity supply of over a certain size, usually over 100 kVA, you should be able to get this information. It should be able to show you in quite good detail what's happening with your electricity supply over the course of a day. That can be very valuable. So if you know if, for example, machine A gets switched off at lunchtime, then you can see the drop in consumption there, and you know how much energy that's consuming when it's actually operating. So that kind of information can be very useful as well. I'd encourage you to use it if you can. So just to talk briefly, and I'll come back to these in a moment or so, about the different places your energy can go. So there's obviously space temperature control. We're all familiar with the heating and air conditioning in office buildings. That can be more complex and for industrial clients, for example, let's say a food production facility where they're trying to maintain a temperature to keep the product at the right temperature, etc., etc. There's other applications like that as well, but it's a very, very big part of the overall energy consumption in most organisations. Lighting, so that can be for just general illumination, for display, for effects. There's commercial equipment, which we're all to some degree familiar with, so kind of run-of-the-mill IT equipment, the appliances that you would see in most organisations. And behind the user-end IT equipment, it's worth bearing in mind that there's also the server spaces that service these, and these can also be very big energy users in their own right, especially in office buildings. Then industrial and production environments. Is anyone here from what you would call an industrial environment today? Industrial organisation? Yeah, okay. So these can be very large users. And the other thing to note is that there can be a huge variety of different applications. So conveyance systems, and the right there, that's a large spiral freezer system. There's automated welding equipment and stuff there as well. Another thing, and I won't dwell on this today, is transport. So that can be on-site and off-site transport. That can be a large proportion of a company's energy use. I won't dwell on it, as I say, but I would point you towards the Energy Saving Trust as a source of good guidance on managing your transport energy costs as well. Okay, so we've had a quick run through some of the different end uses of energy there. From my experience as an energy assessor or an environmental engineer, I've managed to see how energy is managed in a whole range of different organisations. I would say with some degree of certainty that there's no one system that would work for everyone, but what you can find is usually there's common traits to energy management systems that don't work. So I'll talk in a bit more detail about these, but things to consider would be policy. Is there any form of energy policy plan? Is there any plan for actual energy reduction projects in place? The people and resources that are involved in energy management in company. How energy is measured as well. Is there any sort of analysis done? Is the energy data they use reliable, etc.? And then how energy integrates with the other business activities, etc., and how that feeds into investment decisions and so on. So bad practice, where things are usually not as good as they could be, they have no energy policy at all, no simple statement of what the company hopes to achieve in terms of energy management. Now, I wouldn't say that it's necessary for every size of company to have a formal energy policy, but it can be a useful thing to make sure that everyone within the organisation understands that it's their responsibility to try and manage energy. Other bad practice features would be setting unrealistic objectives, overloading people with work, or trying to get them to achieve the impossible. Or one thing that you see quite a lot is just copying from one organisation and using ineffectively and without any real forethought as to how a particular policy is going to work in their organisation, and also policies that are overlong, difficult to understand, and not really allocated to anyone's responsibility. Every company I've been to that's managing energy well has a plan in place as to what they're actually going to do to achieve energy reduction. So they have a list of projects which they've prioritised. They've thought about how much they're actually going to save, how much they're going to cost, and what the next steps might be in terms of the investment or the staff time that would be necessary to achieve those improvements. If there's no one managing that process, or if there's not a set of a programme of energy projects in place, then you'll find that the organisation will generally go nowhere in terms of its energy management. The people that are involved are also key in terms of energy management. Very often you find that where energy management's ineffective, energy is the responsibility of a single person in the organisation, and that can play out in a number of different ways. One way is that the person involved has little responsibility and has too much to do anyway, so they're not going to be able to get to it, and they don't have the responsibility to be able to make decisions, so that's an immediate recipe for failure. Another thing is it's given to someone with responsibility, but they are just paying it lip service, and they're not really planning and doing anything with the energy policy. It's just a front. Another thing that I notice quite a lot in some organisations is that there is an individual within an organisation who is thought to have the greatest degree of technical expertise in terms of energy efficiency, and so everyone will defer their decisions based on what they say. That again can be a mistake, because you often find that the person doesn't know as much as they think they do about energy, and they're making the wrong decisions sometimes. So you always find it's healthier if the energy management's distributed amongst a number of people in the organisation. It always helps to be able to do that. Measurement and actually analysing the data to get an idea of how you're performing in terms of your energy improvement. The two extremes there I would advise you against, one of which is doing pretty much nothing and just relying on estimates that you get for bills and not really thinking about your energy consumption. But the other extreme, which can be equally damaging, is doing too much. I was at a public sector organisation earlier on in the week who have just spent £100,000 on sub-metering for a range of their properties. The sub-meters have been in place for about a year and a half or so, and no one had actually realised in that time that the sub-meters weren't working. They weren't working. They spent £100,000 on this, and they thought that because they'd installed it, they'd made the savings that would be associated with having energy metering. But it took us to come in and find out that none of them were actually working effectively. They were all wrong. So that's an example of trying to do too much and gather too much information. Investment bad practice. I'd mentioned earlier on, sometimes there can be a person at the top of an organisation that vetoes every decision in terms of energy improvements. You don't need to do everything every project that comes your way in terms of energy efficiency. So you don't need to act upon every suggested energy improvement, but you should think about each one on its own merits and make a decision based on how you think it will reduce your costs, how many other knock-on benefits it might have. It might make your process operations easier to manage, etc., etc. So where energy improvements are just vetoed most of the time, you find that that's a company that's not going to go very far in terms of its energy management. Okay, so we're about halfway through now. I'll talk now a little bit about some of the case studies, some of my own personal experience, and some practical tips and best practice. This chart came up earlier on actually in another fellow's presentation that was involved renewable technologies. And what the point he was trying to make was that very often the easiest, most cost-effective means to managing energy is some of the simplest things you can do. So you can see in this chart that the most cost-effective actions are on the bottom left in green, and those that have the longest payback periods are in the top right. Now, this chart was produced about 3 or 4 years ago, and how the actual positions of all those different actions would play out would depend very much on your organisation, and they'll change over time based on equipment costs and stuff like that. But you can see, just as a kind of general observation, that simple things like energy management systems and monitors come out very well in terms of their payback, as opposed to things like solar water heating and solar PV, which are up on the top right there. So those are the least cost-effective means to reduce your energy consumption. In between, there's a range of different things like heating controls, low energy lighting, and some other renewable technologies as well. A good starting point, if you haven't had a chance to consider energy in your organisation, is to go and actually just have a walk around survey. Just take a bit of time, go around and look at the equipment, the processes, the people, and how energy is being managed. And this particular guide here is quite a good starting point, CTG 055 from the Carbon Trust. So the actual end users for energy, heating and air conditioning, and temperature control. The things you might want to consider for that would be initially some of the simple things. So the control of the heating in your office, it's worth noting that very small reductions in the maintained temperature can make a big difference to your bill over the course of a year. If you don't have good control of the heating or the air conditioning in your office, you can make an investment and buy improvements to that. So if you have, for example, radiators with hand valves at the moment throughout your office, you might want to invest in things like TRVs. There's more sophisticated control systems available for the centralised boiler systems as well. You may also want to think about the actual efficiency of the heat or cooling generating plant itself. So if you have very old boilers, you may wish to look at higher efficiency in condensing boilers. You may even want to look at the fuel you're using. So for example, if you're using fuel oil at the moment, is it worth looking to see if you can get a gas connection, or if there's an alternative fuel type that might suit your organisation better. Related to heating and temperature control is the actual building performance itself. So you can see there in this chart, what I'm trying to show is that if you have no insulation at all, or very poor insulation, then you can make a very big saving even by applying small amounts of insulation just to improve your building fabric. Typically for a domestic property, you'll get a payback on loft insulation for about 2 years, and something comparable could be said for a commercial organisation where the actual running hours of the site are similar as well. Something that's often overlooked is infiltration and ingress of air into a building. So I'm talking about through doors and windows, services and vents. But also one thing to consider is the movement of air between heated and unheated areas in a lot of factory environments, for example. And these can often have a very large impact on your energy consumption over the course of time. Another thing to note is that it's very easy actually to seal a drafty door or a drafty service void in a building as well. So it's not a difficult thing to tackle. Another thing that's often overlooked is the actual services insulation, so the pipework for your boiler system, and as well as the pipework, the valves, so the isolation valves. You can buy Velcro jackets for those, which will make sure that those are well insulated as well, and that can have an even better payback. That can be like 1 year. So it's worth having a look in your boiler house to see what's in there at the moment. If it's all bare pipe, you might want to think about investing in that at some point. There's a whole range of publications there from the Energy Saving Trust you might want to look at, and also from the Carbon Trust as well. Coming on to lighting, one of the things that you may well be aware of is that in the last 5 or 6 years, LEDs have become better and better and probably more cost effective in terms of the cost and the light output and the light quality you get from them. So you can see in that chart there that they're on a par or comparable with fluorescent lights as of 2010, and they probably get better in the interim as well. We've done a number of projects recently where we've redesigned the lighting systems for buildings, and that's involved a mixture of LED and conventional lighting systems. So it's worth noting that good T8 and T5 fluorescent tubes, like you're probably all familiar with, are actually comparable with LED in most circumstances. And in some cases, the colour rendering or colour temperature for LEDs isn't quite there yet. So, for example, we did a project in a health centre where we were able to apply LEDs in the corridors and the circulation spaces, but because of the colour temperature that we're looking to achieve in the clinical environments, we found that the LEDs weren't quite as good as the fluorescent lights. So it's not a case of just stripping out what you have at the moment and replacing it with LEDs at the moment, although some of the fittings are very good. Lighting controls are another thing to take into account, and very often the best way to manage that is to actually have staff who are trained and aware and know what they're doing in terms of lighting control. You can aid that by making sure that light switching is well labelled and people understand what they're switching on and off and understand that they're encouraged to do so. Other things you can consider are motion and occupancy detection through PIR, microwave and ultrasonic, and also daylight control. Does anyone have that in their office at all, or the building that they use? Or? Yeah. We find that it's used with varying degrees of success. For example, I was in a building yesterday actually where someone decided to put PIRs in the cleaning cupboards. So even though you wanted to open the cupboard for a couple of minutes or so, get where you wanted and get back out, the PIR meant that the light stayed on for half an hour and you couldn't do anything about it anyway. So sometimes these can be used erroneously, I would say. So we've talked a bit about some of the kind of primary technologies that you're most familiar with. I'll talk now about some of the sectors that I've dealt with and maybe you're familiar with as well. So commercial sector, so by that I mean the offices, hotels, retail environments and so on. What you'll find, as I mentioned earlier on, that a very large proportion of the costs relate to heating and cooling, and very often as well that you can make very good savings on those costs just by making slight adjustments to your controls or improvements to your controls. Lighting is also something that can lead to good energy improvements, and I'd mentioned IT server spaces. You can do something about you very often do something about the maintained temperature or the temperature control in those spaces as well, and that can make a good dent in your energy consumption. An example here was a shopping centre that we engaged with in 2009 and did a general energy survey for. And like many other shopping centres, this one had something like, I think, 100 retail outlets. A lot of the energy was being used in heating and conditioning and ventilating the space, so they had an awful lot of air handling units drawing heated air into the space. And the control of those left something to be desired. We were able to go in and quickly identify a series of improvements. So, for example, setting back the operation of the heating equipment overnight, slightly reducing space temperatures as they were maintained, and also reducing the amount of fresh air that was brought into the building as well. The way the systems had been commissioned, it was quite energy inefficient. So you can see there that from that, the energy survey there on the purple graph, as the site trialled some of these improvements that we suggested, they made a good improvement, and eventually they reckoned they'd saved something like 30% of their electricity and gas costs, and that was all pretty much at no low cost, so quite an encouraging story there. Industrial and process sector, so energy is used in a huge range of different ways in these environments. So there's on the left-hand side, there's clean rooms there, which use a huge amount of space conditioning energy, and then there's metal processing and workshops and so on that we're all familiar with. Case study there, we engaged with a pharmaceutical manufacturer where they had taken on a site which had been occupied by a very large company, a pharmaceutical company as well previously. Now, the company that we'd engaged with had an energy bill of something like £600,000, £700,000 a year. So they were a big consumer in their own right, but the site owners had previously had been even larger. So what they found was that the centralised heating plant, i.e. the steam boiler systems, and the centralised chiller plant was way, way bigger than they actually needed. And it was at very low load for a lot of the time. So generally, when equipment's oversized, it's a good indication that it's going to be inefficient, and that was very much the case with particularly their steam boiler system. We were able to identify improvements to include replacement of the steam boiler, which they went ahead and did, and also improvements to the steam condensate return to the heat raising plant. We also looked at their actual fuel use as well. They were using heavy fuel oil. We investigated getting a gas connection, which was in the end too costly, but they ended up using liquefied natural gas as well as an alternative fuel type, and they made good energy savings through that at the end of the day too. I mentioned earlier on how companies use their energy data and how that can make them effective energy managers. This is a company here, and I've got a couple of screenshots of some of the analysis we did from sub-metering, etc., etc. This is a company that basically manufactured fittings and appliances for kitchens and bathrooms. They manufactured a huge number of different products, but they used a very simple benchmark, if you like, to indicate how much energy they expected to use over the course of any given period. So it was basically kilowatt hours per unit produced, regardless of what that unit was and how much energy that unit consumed. What that led to was very poor predictions of how much energy they were going to use, which caused quite a lot of friction between the production team and the actual financial team. They were trying to set budgets for energy, and frequently they were wrong. So we were able to go in with a combination of sub-metering and using some data analysis to actually develop much better predictive tools for the company based on the different types of products that they produced. And what that allowed them to do was set budgets for energy much more effectively, also be able to identify much more accurately when their energy performance wasn't as good as it could be, so when machines were being left on, etc., etc. And that was a real benefit to both the engineering team and the actual finance team as well. Just running through some of the things you might see if you undertake a walk-around survey that we were talking about earlier on. So one of the commonest things is unnecessary use of light. You can see lights being used at or outside the perimeter of the building during daylight hours there. Some condensing sets for an air conditioning system which are being blocked up, so it won't be working as effectively as it could be. It's an example of pretty poor energy management there. Apparently the storage heater is uncontrollable, so you need to open the window at all times, etc., etc. And we're talking about the insulation on services, distribution systems, so your boiler system, etc. That could be improved. You could put Velcro jackets on the valves there and reduce the heat loss for that system over the course of the year. So that's basically what I wanted to cover. I'll point you in the direction of, obviously I have half an hour or so to talk about energy management. It's quite a broad subject. There'll be a lot more things I could have talked about, and hopefully rather than give you a full impression of the subject, it maybe raises some questions with you, and you can go and check that out yourself. But in terms of sources of assistance, there's obviously Invest Northern Ireland itself, the Carbon Trust, the Sustainable Energy Authority of Ireland as well has some good guidance too. There's some good guidance on purchasing specifications for particular products, for example, for new air conditioning systems on the energy technology list as well. There's also industry-specific guidance you might want to look at, so Lighting Industry Federation, which is a kind of trade body for lighting, has some good information on the kind of good practice and potential pitfalls from lighting refurbishments, and also some of the larger manufacturers and suppliers, like for example Spirax, Sarco. They have some very good tutorials which are quite robust in terms of energy management and understanding the different energy efficient technologies that you might apply. Also, you'll be looking to see where you can get financial assistance for this. So there's business loans available through the Carbon Trust, and there's also the Resource Efficiency Capital Grant Scheme through INI, which would have to be tied to some level of water and waste saving, but could also take into account energy savings as well. And also there is support in terms of consultancy and guidance available through Invest Northern Ireland as well. I suggest that the representatives from INI are probably the best port of call in following up on some of the topics we've discussed today.